Despite the apparent variety of materials in the world around us, we know that everything is made up of just one thing, matter, which itself is composed of a handful of subatomic particles. But when the universe was born, about 14 billion years ago in the Big Bang, two types of matter were created: ordinary matter, of which we and everything else around us are made, and antimatter, a kind of opposite version of it. The existence of antimatter was first predicted by a British scientist called Paul Dirac in 1928. Today, we know antimatter exists because we can find traces of it in cosmic rays and because scientists have made tiny amounts of it in particle accelerators. Now, the universe is vast, but it all seems to be made of matter. So where did all the antimatter go? When matter and antimatter come into contact, they annihilate each other, releasing lots of energy as they do so. In fact, a collision between just 1 kilogram of antimatter and 1 kilogram of matter would release the same energy as exploding 43 million tons of dynamite. We think that equal amounts of matter and antimatter were created in the Big Bang. But something happened in the first minute of the universe, we don't know what, to shift the balance slightly in favour of matter. So when matter and antimatter destroyed each other, some matter was left over. And this is the matter that went on to form the universe that we live in today. Scientists don't understand why there was an imbalance between matter and antimatter. In fact, this is one of the biggest mysteries in science today. We do know, though, that antimatter is like a mirror reflection of matter, but not quite. If you reflect a picture in an ordinary mirror and then reflect the reflection, you end up with an image that's indistinguishable from the original. Antimatter is like matter that has been reflected in such a way that when you try to reflect it back again, it doesn't quite go back to looking the same as before. We think that understanding this process, which we call CP violation, will help us understand why we live in a universe made of matter and not antimatter. But to really understand antimatter, we need an experiment that can recreate the conditions just after the Big Bang. And I'm one of thousands of scientists from all over the world that are working together to build a machine that will do exactly that.